Hey folks, in this video we are going to look at the finite sum of a geometric series, meaning a series that ends. We're only going to add up the first 20 terms in the example we're going to do. But first I want to talk a little bit about a geometric sequence and what it is and how that relates to geometric series. But a sequence is when we just kind of list the pattern of numbers with a comma, but the series would be if we kind of had the plus signs and we were adding these all up. So I could say I'm adding up the terms of a sequence or I'm evaluating a series. It doesn't really matter. But I want us to first understand why we call this a geometric sequence or series. And what we have is a geometric sequence or series is when you multiply to get to the next term in the relationship. So we're not adding or subtracting, we're multiplying, and we're going to call that number that we multiply by the common ratio, and we'll use r to describe it. So some number times r is 100, times that same number r is 40, so on and so forth. And if you're not good at just kind of looking and doing that math in your head, we can always calculate r. If we know 250 times some r value is 100, we could solve that equation by dividing by 250 on each side, and r would be equal to 100 divided by 250, or 0.4. So we could quickly identify that common ratio of 0.4. And we know that 100 times 0.4 is 40, and 40 times 0.4 is 16, so on and so forth. Now that we know the common ratio, the other thing that you need to know, and I've got another video that unpacks this more in depth, I'll put a link to it in the video description, is that our explicit rule to find any term in a geometric sequence is this. I'm going to take my first term, my first term, a sub 1, times my common ratio to the n minus 1. So this is the equation that could find the 20th term in the sequence if we wanted it. And we need to know and understand this to understand what we're going to do on the next slide. So on our next slide, we're going to derive how to find the sum of a finite geometric sequence, or aka evaluated geometric series. Now, I want to be able to do this without listing out all 20 of those terms and adding them up, because that would take forever. What if I said added the first 100 terms, right? Well, let's start with this relationship. We know that to find any term in a geometric sequence, we take our first term times our common ratio to the n minus 1. Now, let's kind of expand this out. So to find the sum of the series, the S sub n could represent the sum. I would take my first term plus, to get the second term, you take your first term times the common ratio. To get the third term, you do the first term times the common ratio twice, right? And we could just kind of expand this out until we get to the nth term in the sequence, which is really just our rule to find it. So I've listed out the series, and I'm trying to be very generalized here, but this is a way to represent the sum that we want. Now, the way that we are going to find this sum quickly and easily depends on what I call a little party trick, meaning you're not going to know to do this unless I show it to you. And what I'm going to do is I'm going to rewrite this same representation of our sum on the row below it, but I'm going to multiply both sides of the equation by r, our common ratio. And here's what that looks like. This right here, our sum, becomes r times the sum. Our first term becomes our first term times r. And then here, instead of a sub 1 times r, it becomes a sub 1 times r squared, because we multiplied every term by r. Anything I do to this side, I have to do to this side. So whenever I multiply both sides of this representation by r, you get this row below it. Now, what we're going to do next, once again, this is why it's the party trick, is let's subtract these. So I want you to maybe pause the video and look at this. I know that that's like, whoa, that's a weird subtraction problem, but have a look at that and see if you can guess what's going to happen whenever we subtract that. Now, if we look, the left side of our equation, we can see these are not like terms. So the left side of our equation is just going to be our sum minus r times the sum, and we'll come back to that later. But if we look over here, let's subtract everything that's like terms. Well, our first term, there's no like terms with it, so I'm just going to copy down my first term, because there wasn't anything, to subtract from it. But then look right here. This term will end up subtracting this term right here, and don't those two match? So this minus this, that would just cancel. And this minus this, that would just cancel. And note that for every term on the second equation, there's a matching term in the top. And we're subtracting. So it's going to cancel out everything. Oh my gosh. Until we get to this one right here. So we have our a sub 1, and then we're subtracting this a sub 1 r to the n. So let's solve for the sum over here, because remember, we're trying to find the sum of this. So I've got two terms that both have s sub n here. So I'm going to factor out that s sub n, and that leaves me with 1 minus r. Over here, my two terms both have an a sub 1. So I'm going to factor out a sub 1, and that leaves me with 1 minus r to the n. And now we're almost there. Remember, we're trying to solve for s sub n, so I want to get rid of this 1 minus r. What I'm going to do is I'm going to divide by 1 minus r and by 1 minus r, and this is our relationship. I'll write it over here to emphasize it. To find our sum, we're going to do our first term times 1 minus our common ratio to the nth power divided by 1 minus the common ratio. This will allow us to find the sum of the first 20, 30, 40 terms like that. And so write that down, store that in your memory banks, label it with what it is. It's sum of a finite geometric sequence, and then let's work one example problem. So I'm going to come back to the example that I listed on the first slide. It says, evaluate the sum of the first 20 terms of this sequence. So what we know is that our relationship's right here. To find our sum, I've got it up top. To find our sum, we're going to do our first term times 1 minus r to the n over 1 minus r. And for this particular problem, to find the sum of the first 20 terms, we're going to take our first term, which is 250. I got that from right there. Times 1 minus, and remember, I already found the common ratio for this on the first slide. That's going to be 0.4 raised to the nth power over 1 minus 0.4. And this is going to give me the sum of the first 20 terms in that sequence. I didn't have to list out 20 terms and add them up. This will do that for us. And I've already done the calculator button pushes over here to the side. It's going to be basically 416.6 something, roughly. Because you can imagine these get to be really tiny decimals after a while. So it's going to be about 416. But the main moral of the story is that is your formula. That's how you'll find the sum of a finite, meaning a series that has a stopping point, geometric series.